All right, moving on here, we have some floor plates, and I just want to give it some structure, right? I don't need to give it all of the structure, and in fact, I'm not going to sit here and design an accurate structural system with you. But if this is going to be a building that is sort of like an exterior, like what we're studying is the exterior condition, and I want to be able to see the structure on the exterior of the building, I'll have to show the structure that's going to be present just beyond the facade, right? So I have the depth here where the facade's going to be, and then I'm actually going to have some structure underneath this. So I'm going to put a simple truss. I'm not going to do anything crazy right now for this, but simple truss that goes across here, and that's going to be behind our facade. So in order to do that, I have a few options really. I could go back to the original surface, and I could subdivide that surface, and then I could just draw a bunch of facades off of it. Or if I go back to this surface right here, and I isolate the edges that I want, I can extrude them down in order to generate the truss element. Now, something to be aware of is that right now this is a very regular and regimented system, so all of the trusses are going to be the same. If you have something that's much more complex, your trusses might not be the same, and so you're going to have to do some kind of variable to it. And I can show you a little bit about that down the road, but I want you to understand how to do a simple one first. Okay, so with this, I'm going to deconstruct all of these surfaces. I'm going to do something that I just suggested Richard do, and that's label this so that I remember what's what. So this extrusion is the floor slabs. All right, so from this surface, I'm going to have to deconstruct it so that I can isolate the particular edges that I need. And those edges are grouped right now, and so I'm going to have to list item, and I need to figure out which ones exactly I need. So that'll be a slider from 0 to 12. So list item 1 is one of the edges that's against the column there. You can see that right there. Index item 0 is against the column. Index item 1 is one of the edges I want. Go over one more. Number 4 I want. Number 7. And number 10. Now, bear in mind that the more complex the geometry you have, the more difficult using list item for this sort of function is, and you might want to use face clashing instead. That's probably, could be a better option when it's a very complex form. So param panel, we'll put those numbers in. 1, 4, 7, 10. Boom, there we go. All right. Hang on. Okay. So something I think I want to do here is I want to try to apply my definition that I used for the truss assignment for the truss bridge, and see if I can just take that and apply it here. So make sure that you save your file first. So save doc. And then I'm going to open that other document, the truss explorations file, which, if you recall, was all based off of a curve. Okay, that's important to know. So with this definition, I'm going to kind of pull this back and group the entire thing. Yeah, you can do this too. And then I'm going to copy and paste into here. So now this kind of is a very, very giant definition that's essentially going to create a truss on parts of my model. I know that it's not going to work for the skinny versions. It probably will only work for the long version. So I will reduce the numbers here. I'm going to need just 1 and 7 instead of 1, 7, and 10. Oh, whoop, sorry, wrong ones. I need 4 and 10, not 1 and 7. Yeah, there we go. Save the file again, I would suggest. And also save the Rhino file, just because it's going to calculate a lot here. So 4 day 4. All right, and just kind of taking a quick look through to make sure that I'm not, screwing anything up here. I know that I have one curve input, and I can kind of flow through all the way, and I can see that I'm going to eventually create. I think this was the wrong version, right? Wasn't that the wrong version? I think I did that one as like a wrong version. Anyway, so that comes down here. This is my bottom curve. The top curve gets generated up here based off of this, so on and so forth, right? So all of that gets generated off of that. So let me go to this, and I'm going to plug it in, moment of truth. And it'll calculate for a while, so let me pause the video. Okay, so it did work. I decided last minute here to make sure that I did just one item first. So that one item, I flattened the list, which was important, and then list item just to grab one in order to test it and make sure it works. So with this, I'm going to change all my settings, make sure it's right and proper and it fits right before I plug in the rest of them. So I'm going to go over here and just start operating on it a little bit. So first and foremost, the number of subdivisions can actually change. So we can reduce this down to another number. Oh, no, I probably shouldn't have done that so hastily. In fact, 7 subdivisions is probably proper. That might have actually crashed it. Hang on. All right, so I guess I'll just stick with 6, but 6 should be fine. This is an operative subdivision, so that's not something I want to change. And if you really wanted to, you could pull all these variable figures like back here to the entrance so that you can just kind of work on them separately. I'm not going to do that right now. I might clean it up for you guys later when I save the file. But anyway, so this is the height of the thing, so it's 20 feet high, and I probably want to make that much, much smaller. In fact, I probably only want to make it like 3 feet, something like that. And that's going to make it really, really short, and by doing that, I might have to increase the number of subdivisions, but I'm going to leave it like that for now until I get to a point where it's proper. There we go. Actually, that kind of looks okay. I have a corner issue that I'll have to resolve later. So other than that, I think one of the things that I want to fix up is the offset is 1. The offset probably needs to be much smaller. I forget what this offset did actually. Oh, that was the wrong one. Never mind. We decided to abandon that path. So back here we have the bottom thickness, and so this is the thickness of the bottom chord. I'm going to just kind of throw this out there. Ultimately, I don't think it matters which one you do first, but with the thickness of these chords, it might make sense to go with the last items first, so that when you make something smaller, if it's supposed to be subtracting, you might mitigate it calculating something unnecessarily. So I'm going to start with my vertical thicknesses. So these are the diagonals. I'm going to change these to like 0.25 feet. And there you can see that it made it much, much smaller. And that might actually go down even more. But my top thickness, I'll make like a 0.375 feet. And then the bottom thickness, I'll make again 0.375, so slightly larger, not much larger. So then I also have to change my top chord and my bottom chord depth, which I believe is right here, this unit Z here. So the bottom chord I can change to appropriately to match if I wanted it to be square. So I'm just going to be easy here and just make it match by dragging that 0.375 into it. And there you see it corrected. And I'll do the same thing here. And there it is corrected. So over here in this condition, let me select it so you can see. There you go. So in this condition, it's, the corner conditions might not necessarily look exactly the same as you designed them in the original definition. In some cases, that's going to be okay. In other cases, it's not. For instance, right here, this extends a little bit too long. So maybe rather than our extension factor, which I forget where it is, 1.02, maybe we switch this to a 1.01. Right, so that makes it a little bit shorter, just in case, and you could even probably just leave it at 1 in this case. Yeah, that should be fine. Oh wait, no, there is it does have to be a 1.01. So whether or not you see this is kind of like, it depends. Like if I'm going to be looking at my building from this far out, I'm not going to see a detail like that, and you guys don't have to worry about it. But if you're doing an interior render and you're going to be looking at it, this close to it, then you might see it, and you might need to care about that kind of thing. So the other thing is this truss is vertical, and I actually want to flip it to make it go down. And so the way I'm going to do that is to just rotate it around the center line. So basically my bottom chord, this is going to be my bottom chord construct line. That would be the bottom chord curve, which should be that. So I can make a copy of the bottom chord curve and make that wireless. Oh, it is wireless. I'm going to put it out here, and I'm going to use that as my rotator for this, the whole thing. It'll calculate them all in place the way they are, and then it'll just rotate them all down. And the truth is, in reality, it'll free up some of your computing power if you were to just build it going down instead. And it might actually be kind of easy, but I don't feel like right now going through the process of reverting this thing to go downward. So I'll just do a flip at the end, and it should work. It'll calculate longer, but it'll work. So I'm going to go to Transform, Euclidean, and Rotate, but I'm going to use the line-based rotate axis. And so the rotate is going to be this item right here. You'll see it default to rotating down there. But the bottom curve is going to be the axis. Now you see it rotating outward. And then I'm going to change the rotation angle to be 180 degrees. So that's, under math, I'm going to convert from degrees to radians. And I'll put a slider, 0 to 180. Actually, this is going to be a static slider. 180. There you go. This turns off. In fact, everything in here turns off. So I'm going to save this real quick, and then I'm going to modify this just to make sure that it works in multiple applications. So I'm going to add the next index value onto it and give it a test. Save. Turn this to multi-line, and then add index value 1. And that'll calculate for a moment, and then I'm just going to make sure that it's working. Oh, it's not. Interesting. Why not? Oh. Oh, yeah, you're right. Graphed. Sorry. Good call. So yeah, now they're coming through as two separate items, and so what's happening is it goes through the whole process, and then when it gets to this point, it's saying, well, you've got geometry down here, and you've got geometry up here, and you're telling me to join them together, but I can't because they're in different places. So that's the error, and that's why they have to be grafted. So at that point, what you're really going to do here is go to set tree, and you're going to graft it on the output here. But since I'm just testing two of them, I'm going to graft this list right now, and then plug that in. I'll come help you out. Okay, and all right, that's interesting. Well, I don't know why it's doing that, but we did get it to go to the other side, so that's good. I'm going to troubleshoot this, and then I'll follow up on this video later.